Okay, this is 7.5 homework help. First problem wants us to simplify this expression as much as possible. So we've got the sign of a double angle right there, and this is we've got multiple angle formula sheets on our formula sheet right here. Sine of 2u equals 2 sine of u cosine of u, so we can rewrite the top as 2 sine of x cosine of x, just following that formula. And then from there, obviously the cosines cancel, and our answer is just 2 sine of x. Okay, the next problem, cosine of 22.5, that's half of 45, so I'm going to write that as 45 over 2. And then I'm going to use the half angle identities on the formula sheet. So if you scroll down to the cosine of an angle over 2, it's plus or minus this right here. So I'm going to write that down. Now u in this case is 45, so I can write 45 right here in the formula. And then we need to figure out if it's plus or minus. So 22.5, if you look at where that angle is, that's over here in the first quadrant where the cosine is positive. So we're only looking at the positive here. Now we can simplify this. The cosine of 45 is square root of 2 over 2. So it turns into 1 plus the square root of 2 over 2, all over 2. And then we're going to simplify this some more, so get a common denominator right here. Make that 1, 2 over 2. And so you can simplify to the square root of 2 plus the square root of 2, all over 2, all over 2 again. Let's multiply by 1/2 instead of dividing by 2. And that turns into a 4 in the bottom then, right here. So then we can simplify this. I guess we could either enter it in like this or evaluate the square root of the denominator. And then I'd write this in. So either way you want to enter it in like this. You got to be careful with your parentheses, but either of those answers should work. Okay, the next problem I'm going to do the same thing. 11 pi over 8. I'm going to convert this to degrees though first. So multiply by 180 over pi. Pi's cancel, and you get 247.5. Now anytime you see this 247.5, so I'm doing this in degrees, so it makes more sense. But anytime you see this, you want to think, what happens if I were to double the top and divide by 2? So multiply the top by 2 and divide by 2 to undo that, so to speak. That way you can get rid of this negative. And then it becomes the sine of 495 divided by 2. Now if you check 495 on your calculator, if you subtract 360, you get 135. So it's really this angle over here where it's a 45, 45, 90 triangle right there. So that's an exact value we have from our unit circle, so that's good. So we can just use the sine of half an angle formula, which is right here. 1 minus the cosine of u over 2. Now u is 495 in this case, so I'm going to write 495 right here. And I need to figure out if it's positive or negative. We're talking about the value of the sine here. The sine is positive over in the second quadrant, so I know I'm just working with a positive. Now cosine of 495 is the same as cosine of 135 on your unit circle, and that's negative square root of 2 over 2. So I'm going to replace this with negative square root of 2 over 2, in which case I get, now double negatives cancel here. Now I'm going to get a common denominator right here, 2 over 2. So this simplifies to this right here. And then I can multiply once again by 1/2 instead of divide by 2. And that turns into a 4 in the bottom. And then I can simplify it a little bit further, I guess, if you once again evaluate the square root of 4. So the square root's not in the bottom now. It's just 1/2. And you could write that as 1/2 out front if you wanted it even, if that's easier for you. But you do have to use parentheses carefully again. Okay, the next problem gives us the tangent of some angle alpha is right here, and it tells us that alpha is between 90 and 180. So I'm going to draw a reference triangle here where I can draw alpha in. Now technically alpha is this angle here, but it doesn't matter. We use this as a reference triangle. So tangent of that angle is opposite over adjacent. So actually this is negative and this is positive. Now if you do the Pythagorean theorem, you get 7 for the hypotenuse. So what they're asking for though is the tangent of alpha over 2. So if we look at our formula sheet, the tangent of, we can use any one of these formulas right here. I'm going to use the middle one, I guess, because it looks pretty easy. 1 minus cosine of u over sine of u. I mean, we're using alpha instead of u. So this is what I want. My angle alpha, I'll label it right here, even though we really know it's this angle. I'm going to use this reference triangle though, so it's 1 minus the cosine of alpha is adjacent over hypotenuse, which is negative square root of 13 over 7. And the sine is opposite of our hypotenuse, which is 6 over 7. So we can simplify this then. Double negatives go positive here in the middle. I'm going to combine the numerator together by getting a common denominator. So I'm going to write 1 as 7 over 7. And it becomes 7 plus the square root of 13 all over 7 divided by 6/7. I'm going to multiply by 7 over 6 instead of divide by 6 over 7. The 7's then cancel, and I get 7 plus the square root of 13 all over 6. When you enter this in, make sure to use parentheses, but that should be our answer right there. All right, next problem gives us an angle theta as pi over 8, and it says find the tangent of 2 theta in exact form. So let's look at our formula sheet. Right here we have a formula for tangent of twice an angle. Actually, an easier way to do this is to just, if you convert this 2 degrees, you'll find out it's 22.5. So what they're asking for is a tangent of twice that, which is the tangent of 45. So it's easier just to look right at your unit circle and know the tangent of 45 is the sine of 45 over the cosine of 45, which we know is square root of 2 over 2 divided by square root of 2 over 2, which is just 1. So that's going to be a little easier for that one. All right, the next problem, the same thing. This is theta 60 in this case, so we're looking for the cotangent of twice 60, which is 120. Now 120 is on your unit circle, so cotangent in this case is cosine over sine. So the cosine of 120 on your unit circle is negative 1/2, and the sine of 120 is square root of 3 over 2. So let's multiply by the reciprocal, 2 over the square root of 3, and the 2's cancel. We get negative 1 over the square root of 3, which that works fine. I mean, typically we would rationalize that denominator, but Webwork should accept it like that. If it doesn't, then rationalize the denominator, and that's really negative square root of 3 over 3. All right, my next problem gives me a theta of 90, so the secant of theta over 2 would be 90 over 2, which is 45. So what I'm looking for is the secant of 45, which is really 1 over cosine of 45. Now that we know the cosine of 45 is square root of 2 over 2, so my answer is 2 over the square root of 2 if I flip it, move it to the top. You could rationalize the denominator, but pretty sure Webwork will accept it just fine like this. If not, then multiply top and bottom by the square root of 2 over 2. All right, and the next problem gives me an angle of 5 pi over 2, which is 2.5 pi. So that'd be 450 degrees, and if we divide that by 2, we get 225. So we're looking for the cosecant of 225, which is really 1 over the sine of 225. Now the sine of 225 on your unit circle is negative square root of 2 over 2. So we're going to write this as negative 2 over the square root of 2 if we move it to the top and flip it. And that should be okay. Typically, like I said, we'll rationalize the denominator, but that's fine. Okay, the next problem we're going to try to do this without a calculator. So the cosine of 30 is on our formula sheet. It's our unit circle, square root of 3 over 2. We're going to square that. We're going to subtract the sine of 30. Sine of 30 is 1/2. All right, so when we square this, we get 3/4. And when we square this, we get 1/4. So when we subtract, we get 2/4, which is 1/2. All right, the next problem, this right here, inverse cosine is an angle. So I'm going to call that theta. So if the inverse cosine of x over 3 equals theta, then that means the cosine of theta equals x over 3. So that gives me some clues about how we can draw this. Now keep in mind the inverse cosine is defined from 0 to pi, so my angle has to be somewhere between 0 and pi, and because these are both positive, I'm going to draw my theta here, where cosine is x over 3 adjacent of our hypotenuse. The Pythagorean theorem gives us this side, which is the square root of 9 minus x squared. And now we're looking for the tangent of 2 theta. So I'm going to rewrite this as the tangent of 2 theta, where my theta is right here. Now the tangent of 2 theta is right here in the formula sheet. So let me copy that down. All right, it's right here. Only we're using theta and not u. So we want 2 times the tangent of u, or theta. Now tangent of theta is opposite over adjacent, so that's the square root of 9 minus x squared over x. And then we want 1 minus the tangent squared of u. Now once again, the tangent is square root of 9 minus x squared over x, but we want that squared. So I realize this is a lot of algebra now. All right, let's simplify the bottom first here. So all I did was square the top, and I get 9 minus x squared, and square the bottom, you get x squared. And then I'm going to get a common denominator, so I'm going to make this x squared over x squared. Okay, now I need to distribute this negative sign to both of these terms in the bottom. So this turns into plus, this turns into minus, this turns plus. Now if I simplify the bottom further now, I could combine the x squared and the x squared to get 2x squared. And I could also put the negative 9 there. Now instead of dividing by a fraction, we're going to multiply by the reciprocal. So I'm going to move this up and multiply by the reciprocal, write it down here. And one of these x's then cancel with one of these, leaving this is a 1 and this is also a 1. So now I can rewrite it like this: 2x square root of 9 minus x squared all over 2x squared minus 9. And I can't simplify that anymore, so I'm going to enter that answer in. I know it's going to be really hard to enter in, but that's our answer. So I know it's a little tricky to enter in. You got to use a lot of parentheses, but you can do it. Okay, the next problem gives us the tangent is negative 1/3 and the cosine's positive. If the cosine's positive, we're over here, and if the tangent's negative, that means the sine's negative, because tangent is sine over cosine. So we have to be down here in the fourth quadrant. Well, the tangent here is opposite over adjacent, so this is negative 1 and this is 3. Pythagorean theorem gives us the hypotenuse, the square root of 10. So now I know technically this is my angle x, but I'm going to call this x right here. Now we want the sine of 2x, so we're going to look at the formula sheet for the sine of 2x, which is actually up here. That's really 2 sine of x cosine of x right here. So that's 2 sine of x is opposite over hypotenuse, negative 1 over square root of 10. And cosine of x is adjacent over hypotenuse, 3 over the square root of 10. So this turns into negative 6 over 10, which simplifies to negative 3/5. Okay, next is cosine of 2x. We can use any one of these formulas we want. I'll do the middle one, which is right here. So we got 2, now cosine of x is adjacent over hypotenuse, so that's 3 over the square root of 10. I need to square that and then subtract 1. So that turns into 9 over 10 times 2 minus 1, so that's 18 over 10. Minus 1, so I'll subtract 10 over 10, which gives me 8 over 10, or divide top and bottom by 2, and that's 4/5. And the last one is tangent of 2x, which here's the formula off the formula sheet. So we're just going to plug this in. Tangent of x is opposite over adjacent, so that's negative 1/3. Divided by 1 minus tangent squared of x, so that's negative 1/3 squared. We can simplify. This is negative 2/3 in the top. In the bottom, this is going to be 1 minus 1/9. So I'll get a common denominator here. So negative 2/3 over 8/9. Now I'll multiply by 9 over 8 instead of divide by 8/9. And 3 goes into 9 3 times, and 2 goes into 8 4 times, so it's negative 3/4. And that should work fine. All right, the next problem gives us sine to the 4th of x, and it wants us to use power reducing formulas to get this. So I'm going to be using this formula right here. So I'm going to rewrite sine to the 4th as sine squared of x times sine squared of x, and then use this formula right here, which would give me 1 minus cosine of 2x over 2 times 1 minus cosine of 2x over 2. So now I'm going to FOIL the tops, and I get 1 minus 2 cosine of 2x plus cosine squared of 2x all over 4. Now I'm going to replace this cosine squared using this formula right here. So this is going to be 1 plus cosine of 2u. Now u is 2x in this case, so it's 2 times 2x all over 2. So let me write that right here. And I'm going to make it 2 times 2 is 4x right here. So now I have to simplify all this to get it in the form they wanted it in. So I'm going to divide the 4, so I get 1/4 minus this divided by 4 will be 2 cosine of 2x over 4, plus I have 1 plus cosine of 4x. I'm going to divide the 2 into both of these, and then the whole thing's divided by 4, so I'm going to multiply through by 1/4. That gives me an 1/8 in the bottom of both of these. Now I'm going to add these two fractions together. Get a common denominator. That gives me 3/8 minus this goes in here twice. And this is my answer, but let me put these up. So looking for this number, and this number for A, B, and C.